Hi, welcome to Pi Planet, and we've got a question from surface areas and volumes, which we are solving right now in this videos. So the question says that there is a solid which is consisting of a right circular cone, right? And the height of the circular cone is 120 centimeter and the radius is 60 centimeter. Now this cone is basically standing. It's standing on a hemisphere with the radius of 60 centimeters. So basically what we can say is that the hemisphere, the radius of the hemisphere and the radius of the cone, they both are equal to each other. So, and if we can draw, how would it look like? So it will look like something like this. This is the hemisphere, okay, and this is the circular side of the circular face of the hemisphere, and the cone is standing on it. So the cone would look something like this. Okay, so cone will look like this, and since the radius of both the objects is exactly same, so that means their base areas would also be exactly equal. So this part will be the same. Now it says that the height of the cone is 120 centimeters. So that means we can, if this is the center point of the circle of the base of the cone, that means this is going to be the height of the cone, and the radius of the cone and also the the radius of the vessel is going to be this side. So let's just mark this. This is H, right, and this is R. Now what's happening is this whole object, this whole solid is placed upright in a circular cylinder which is full of water, right? So maybe the cylinder would be like this, right, and such that it touches the bottom. Okay, so such that it touches the bottom. So let's make it little, it should be like this. It's exactly touching the bottom. This is the cylinder which we have. Now find the volume of the water left in the cylinder, right? Now we already know that the volume of the water, what we know is volume of the water left is equal to the water displaced, right, water displaced by the uh, by the cone, right? No, actually what we can say is that volume of the water left is equal to the total volume of the, or we can put it like volume of the total water, right? Volume of the total water minus water displaced, right? Now we already know that the water was in a cylindrical object, so the volume of the total water is equal to the, this is equal to the, this part is equal to the volume of the cylinder. And the volume of the water displaced will be equal to the volume of this object, because this is what we have studied in physics, that water displaced by any object is exactly equal to the volume of that same object. So the water displaced here is equal to the volume of the object which is immersed here. Now object meaning the volume of the cone plus the volume of the hemisphere, right? So this is one question in which we are going to calculate the hemisphere, the volume of the hemisphere, the volume of the cone, and also the volume of the cylinder. All three of them are going to get worked out, and then we'll put this in this relationship, all these values, and we'll get the answer. So let's first identify the volume of the cylinder. So the volume of the cylinder is volume of cylinder. Now we already know that that's equal to pi r square h, right? So pi r square h means pi. R is the radius of the cylinder is 60 centimeter, right? So that's like 60 multiplied by 60 because we are talking about square, and h is 180 centimeters. So that's like multiplied by 180. So this comes to, let's just let's take the help from the calculator. So this is like 60 into 60 makes it 3600 multiplied by 18, 180, right? So that's like 6,48,000 pi. 6,48,000, right, pi, and this is cubic centimeter. Now let's find out the volume of the cone. So volume of the cone is already, we are aware the formula, volume of cone. Now that's equal to 1/3 pi r square h. Now 1/3 pi, and the radius of the cone is 60 centimeter, which is like multiplied by 60 multiplied by 60, and height of the cone is 120. So that's like 120. So finally what we get here is 3600 into 40. 3600 into 40. So that's like 1,44,000. 1,44,000 pi cubic centimeter, right? And now let's find out the volume of the hemisphere, right? So the volume of the hemisphere, volume of the hemisphere. So we know the formula, that's like 2/3 pi r cube, right? So that's like 2/3 pi. R is 60 because the radius of the hemisphere is given as 60 centimeters. So that's like 60 into 60 into 60, right? So this is going to be like 20, and this is 3600 into 40. Yeah, 3600 into 40, 3600 into 40. So that's also 1,44,000 pi cubic centimeter, right? So we have got everything now, and we can simply find out now the volume which is left in the volume of the water which is left in this cylinder. So if we put all these three values in this relationship, then let's first put the volume of the total water, right? This one. So this is like 6,48,000 pi minus the water displaced, and water displaced meaning the volume of the cone as well as the hemisphere. So that's going to get added. So if we add up this and this is the total volume of the object, and that's going to be 2,88,000 pi. So that's equal to 0, 0, 0 and 0, and 14, 8, 6 and 5 minus 2, that's like 3. So 3,60,000 pi, right? So that's the cubic centimeter. Okay, so this is what is left in the cylindrical vessel after the object is being immersed into the water completely, right? So I hope you could understand. This question was also very simple, but was little lengthy because of the calculation which was involved into it. But I hope it was clear and you could understand this. In case you have any doubts, please let me know in my comments and I'll be clearing that. Thank you so much. Have a nice day and bye bye.